that x minus 2 is a factor of k of x, which is equal to 2x to the third minus 5x squared plus x plus 2. Factorize k of x completely. All right, with a question like this, what we want to do is to use long division to help us out. Based on the context, synthetic division would be good, but based on the context of this syllabus, we're going to be using long division to divide through this, and then when we get the quotient, we factorize that again to get the other two factors. So basically, I'm actually looking for 1, 2, 3 factors at the end of the day. Why? Because the highest power of the variable is a power of 3. All right, so let's set it up. So we're setting up having 2x to the third minus 5x squared plus x plus 2. And then we're going to divide this by x minus 2. All right, so we're going to carry out. Remember now when we do these long divisions, what we're going to be using is the x to divide, right? So we're not going to use the 2 to divide. So we're going to say x, and let me highlight this x. We're going to divide x into 2x to the third. We're going to get 2x squared. And then we're going to multiply. So 2x squared times x is going to give us back 2x to the third. 2x squared times negative 2 will give me negative 4x squared. I could just put these in a little bracket, and then we employ subtraction. So if we should read 2x to the third minus 2x to the third, that part is a 0. Negative 5x squared minus 4, that is going to give us a negative x squared. Then I am just going to bring down the positive x and the positive 2. So this is the line that I'm going to be using now as I divide through one more time. We're still using the x, all right? So x into negative x squared, we're left with a negative x. Negative x times x will give me a negative x squared. Negative x times negative 2 will give me a positive 2x. And there we go. And we're going to subtract this again. So negative x squared minus x is a 0. And then x minus 2x. So we have x minus 2x will give me a minus x. And then I'm going to add back down my plus 2. So now this is the line that I'm going to be dividing into. So we have a negative x plus 2. X into negative x is going to give me a negative 1. Negative 1 times x is going to give me a negative x. Negative 1 times negative 2 will give me a positive 2 right there. Then I'm going to subtract again. So let us see what's going on here. Hold on. Good. All right, so we have negative x minus x, and that is a 0. 2 minus 2, that is a 0. So definitely we see that the remainder is a 0, which means that the quotient is 2x squared minus x minus 1. Now, to get the other factors now, we're going to be factorizing this ordinarily. So it is 2x squared minus x minus 1. We could simply say a is 2, b is negative 1, c is negative 1. AC is 2 times negative 1, which is negative 2. What are the factor pairs of negative 2? Factor pairs of negative 2 would be 1 times 2. All right, so we want to get a negative 1. So we're going to use negative 2 and a positive 1, right? So that we'll get back this middle term here that I'm going to be highlighting. Let us take a look. Now, we're going to be writing back 2x squared minus 2x plus x minus 1. We're factorizing this to get the other two factors. For these two, I'm going to factorize using 2x, and then I'm going to be using 1. So 2x into 2x squared, we're left with x, and 2x into negative 2x is negative 1. So if you notice, what I have in the brackets here is the same thing as here, which means the factor is a plus 1. So positive 1, then we have back x minus 1. If you notice that we have x minus 1, it's a common factor. So we'll write it back. And then the other two things, which is 2x plus 1, we'll put that in the other bracket. So then the three factors are as follows. 1, x minus 1, 2, 2x plus 1, and then the original one we got, which is x minus 2. So these are the factors of that polynomial that we had up top. All right, let's look at the other question. The other question is an exponential question. So we're looking at 16x plus 2, right? So we're looking at 16x plus 2. 16x plus 2 is equal to 1 over 4. All right, 16x plus 2 is equal to 1 over 4. Now, whenever we're dealing with exponential functions, what we want to do is to make sure that we can represent both sides using the same base. So we could represent all of these using a base of 4. For example, 4 squared is a 16, and then we have x plus 2. And then 1 over 4 would mean the inverse, right? So this is 4 to the negative 1. Now, as you could see, we have represented the left side with a base of 4, the right side with a base of 4. At this time, we could, what I'm going to do over this side, though, is just to rewrite this in a manner. So I'm going to say, hold on. So in rewriting the left side, let's rewrite the left side in a manner more acceptable. So we have a 4, and then you will have 2 open bracket x plus 2. Now, this would have come about because of this rule. If I have a raised to the n, then this is the same thing as saying a to the n m. In other words, when a power is raised to a power, we multiply the powers to get the final thing. So we embark on this idea in order to represent this piece right there. Now let us continue. This is now equal to 4 to the negative 1. Drop the base. For example, we're going to be dropping the 4s. So we're now left with 2x plus 2 equal to negative 1. Let's distribute that 2 inside. 2x plus 4 equal negative 1. Then let me just put this right here. Finally, 2x plus 4 minus 4 is equal to negative 1 minus 4. 2x is equal to negative 5. Let's divide both sides by 2. My final answer is x equal to negative 5 over 2. So here it is, I'd work out x to be negative 5 over 2 or negative 2.5, all right? Or negative 2.5. All right, the second question here says that given that f of x is equal to 3x squared minus 9x plus 4, express f of x in the form a open bracket x plus b all squared plus c, where a, b, and c are real numbers, all right? So what we want to do with this here is to, let us just name out our a, b, and our c. So a is equal to 3, b is equal to negative 9, and c is equal to 4. What I'm going to do in terms of representing this is just to put it in the standard form where h, which is my b value right now, so my b value is h, which is equal to b over 2a. So let me find that value right now. B is negative 9 over 2 times a, and a is 3. So I'm getting negative 9 over 6. And if I divide through by 3, I'll get negative 3/2. So that is my h. So my h, or my b value, is negative 3/2. Now, I want to find my, I could find my k value, which is a c right now. So my k value, which is a c right now, is equal to 4ac minus b squared all over 4a. 4ac. So this is 4 times a, and a is 3. So 4 times 3 times 4 minus b squared, which is negative 9 squared, all over 4 times A, and A is 3. This is now equal to negative 48. So I'm looking at 12. So this is, no, not negative. This is 48. Yes. So 48 minus 81 over 12. All right. So let us quickly work out that. Let us quickly work out that. All right. So 48 minus 81. So we have a negative 33 over 12. And if I divide through by, say, 3, I'll get negative 11 over 4. So my K value is negative 11 over 4. Now, since I have B, all right, since I have that B value there, which is the H, which is negative 3 over 2, and I have that K value there, which is negative 11 over 4, then I can simply just write it in the form. So the form is, as you could see, 4A is outside and A is 3, open bracket, x minus 3 over 2 square and minus 11 fourth, right? So there it is. We would have had that as we're talking about completing the square. That's what we need. Just getting those and we're good to go. All right. We are very much on our way out. All right, let's go. All right, let's go for the next part of the question. So the question says, it says state, so I'm right here, number 2AII, I'm right here. It says state the coordinates of the minimum point, all right, of f of x. The minimum point is simply the axis of symmetry, which is not this, it's the opposite of that, and that value there, all right, the K value. So in a real term, if I have the negative of the H and the K, that is my minimum point. So basically then, that is going to be positive 3 over 2 along with negative 11 fourth. And that is my minimum point right there. The next question says, the equation 3x squared minus 6x minus 4 equals 0 has roots alpha and beta. Find the values of 1 over a, 1 over alpha, 1 over beta. You're getting 4 marks to do that.